Okay. 9-7. Hey, Mr. Miller. The profit equation. So we have a bunch of equations, right? We've got equations for revenue and expenses, and we first developed them in terms of quantity, right? Q. And then we kind of converted them over to write them in terms of price. And what did we use to substitute in to get them in terms of price and quantity? Remember? Which other function? Okay, the demand function, right? Is the demand function in terms of price, you know, Q equals, so we took what Q was and plugged it into both of those, we got something in terms of price. And when we did that with revenue, we got a quadratic and a parabola, right? Parabola with cheese, pepperoni, right? Yeah, I think I'm gonna delete that thing. Yeah. Just draw it. Never. Delete. All right. I do real quick. I hope this is still up. Show you some graphs of revenue and expense. We can figure out whether a company's going to make money or not. So this is back on page. It's in your book. It's like the start of the section of the book. They give you a bunch of. Can you see these in your book? These are revenue functions, and then in the blue on these two, they have the expense functions, right? So over here in figure D, right? Remember, all your profit is in between the two, right? Revenue minus expense, okay? Now look at figure C. What can you tell me about that company? That's a revenue and expense graph. What? Yeah. So what? So what does that mean? They're not what? This is the expense up here above the revenue. Yeah. Remember, the revenue is a quadratic. Right. They're not making a profit on this product, so they probably either want to go back and review their expense structure, maybe lay some people off, right? You know, because by the way, does anybody know what the biggest line item on a company's balance sheet is for expenses? Usually, salaries, right? Benefits and all that stuff. Huge. So whatever. So this company, whatever product they're manufacturing here, maybe it's not even a matter of them operating it correctly, or maybe it just can't be done with this particular product. Who knows? You know, they're not going to make any money because there's no intersections, no break-even points. Right? So profit is what minus what? Yeah, profit equals revenue minus expense. And we have functions for R and E, right? Okay. And we're going to be working with them in terms of price, like we've converted them over by plugging in the demand function, right? Not so much quantity. So if we draw a quick little graph here. All right, let me put expenses in here. I'll do that in red so it's clear, right? Like that. And let me put a little revenue curve in here, okay? So on that graph, the distance between the revenue, right, and the expense is where the profit is, revenue minus expense. And for the revenue graph, remember the vertex there? Negative B over 2A, find that, right? So this is the price point, you know, it lines up down here with whatever price that is that gives you the maximum revenue. So I got a question to ask you. Do you think that the maximum revenue will also be the same point for the maximum profit? Right. But if I was looking for profit and doing revenue minus expense to that point, right, would that necessarily be the maximum profit where the revenue is also maximum? Yeah. Well, I mean, run this way. It's the largest profit is going to be at the farthest distance between revenue and expense when we subtract them. It might not be that the max revenue is also the max profit, right? So we know that this point is max revenue, right there, right? Your negative B over 2A thing, and find that ordinance, you know, whatever this price here, I'll call it price 1, right? But maybe this vertical distance here, maybe it's longer than that vertical distance there. It could be, couldn't it? So maybe this is the max profit, right? So max profit is found at the greatest R minus E value, okay? So max profit is the greatest R minus E value, okay? Not necessarily the revenue vertex. It could be, not necessarily. The revenue vertex. Okay, so you got to be a little bit careful with that. Okay, and so we'll have to get like a different profit equation here, maybe, right, to really dial in on this. Let me ask you, just so you can kind of conceive of the next graph we're going to put up here. So this point here, right, that would be a break even, and that would be a break even. Everybody agree? Okay. So this expense line, if we're thinking just in terms of profit, this expense line here and here, would that not act as like new zeros of the function for profit, which is profit? Right, right. But wouldn't, so think of it this way. This expense line, is it now acting kind of like this axis here? You see what I mean? Like if I, let me see if I can do this. So if I take that, and I need to control the hang on. Oh, let's see if this works. This would be great. What if I took this, right, and did that? Wouldn't that be more like, you see what I'm getting at? So we could cut, if we get a profit function, right, that expense function would be the new zero of our new profit function. Kind of think of it as being rotated down, if that helps. We're going to do that. Right, so what we're going to end up with today, okay, we're going to rotate it down. So like whatever this break-even price is here, right there, that would be zero profit, you'd all agree? And if I had a profit graph, it would probably start here, like lined up with this, right? Let me do a different color, right? And it might come up here like this. You see what I mean? It would line up with that one, okay? So that when this came rotated down, right, it would be that zero break-even point. Does that make sense? So we're going to have another parabola that looks like that green one. That's going to be just the profit. And this is going to basically represent this area up in here, if you think of it as being kind of really, it doesn't exactly work like that, but I think that's maybe a decent way to visualize it, okay? All right, so let's work out how to get a profit equation. We know it's R minus E, right? Do we have a revenue function? Do we have an E expense function? And we can subtract the two to get profit, right? So let's go take a look at example 1 there in the book. Example 1. So, and they're sticking with that Picasso paint business, right, from the last section. They're staying with this company, okay? So they're using some of it. They're using the revenue and expense that when we got them in terms of price, okay, from the last section. So they want us to get the profit equation from Picasso Paints. And there's the revenue, negative 500p squared, et cetera, expense, right? So profit is R minus E, right? So let's just substitute, right? R is this negative 500p squared. Let me just do this. Profit, so it equals negative 500p squared plus 30,000p minus the expense function. Now I need to subtract the whole thing, so I absolutely have to put this in parentheses because I'm right subtracting it. Okay? Minus the expense function, which was negative 3,500p plus 238,000. Okay? If I was just adding it, I wouldn't, parentheses wouldn't really make a difference because I'm distributing through a positive one. But I've got to distribute a negative one through there, right? You guys know that. That's why you're here. So let's distribute through negative 500p squared plus 30,000p. Now it's going to be plus 3,500p, right? And then minus 238,000. With me, I distribute that negative through. So now we just combine those p terms in the middle, right? Charlie, try to be mature about this, all right?
Doing my best.
We're combining the p. Negative 500p squared. Huh? Yeah, well, you know. 33,500p. And then minus that 238,000. So now we have an actual profit function, a new thing to graph. And that should give us the graph, that green parabola I put up there, right? This is concave down still, right? The negative A, right? Okay? That'll be a concave down graph. Right? So in example 2, they want us to use now a graphing calculator to draw this graph. Okay? So let's click over to example 2. We got that. So this is our, that's our profit function. Yeah, here we go. All right. Now, I mean, we did these by hand the other day, right? We found the zeros where it hits the x-axis, and we found that peak point there. So I know you know how to do it by hand. So now it would be appropriate to use our technology here. So you guys have your calculators, okay? Let's graph it, and I think they want us to find the max price on that, or the price that gives us the max, okay? So let's put that in. Here. Okay. So we're going to use x squared plus 3,500 x minus 2,000. Well, we're going to work that out here in a second. All right. Yeah, we're definitely going to need to adjust our window. Let's think about this for a minute. What would be negative b over 2? So what? Negative 33,500. So what would be 33,500 divided by 500 roughly?
Good question.
Just to give you an idea, like how high do we have to go for that max? How many times does 5 go into 30? Okay, let's say 0.5 goes into 30. Okay, so maybe we need to be up to 500,000, 600,000, like that. Roughly, we're just estimating. And then figure out how wide we need to go. So let's go back and hit our menu button. Window zoom, window settings. Let's go next from 0 to, I don't know, let's try $85. That's our key, not dice. And we'll try a Y from 0 to 500,000 maybe. Too much for what? Can you see the whole graph? Yeah, okay. So there it is. And so let's make a rough sketch of it here. Back in our notes. Did you get it? Maybe you make sure you put like P or that square in there, maybe do something like that.
Yeah, last time my calculator like kept not giving me the correct school.
Yeah, you're down there. Yeah, I was gonna check your equation. Okay. Yeah, that'll make a big difference. All right, so back here, let's make a rough sketch of this here. So we did the TI, right, and we did like 0 for X to, what do I say, 85, right? And I think we did the Y from 0 to 500,000. Or something that's just wide enough to fit. You know, too big and the thing will be so tiny you can't analyze it, right? And so we roughly have a graph like this. This is our P, and this is our capital P, so I'll just put money, I don't want to confuse you, right? So where did it end? Whoopsie daisy. Okay. So that looks like it's out. Oh, I gotta hit the trace button, right? What? Dummy. Menu. Trace. Trace. Let's just get an idea. Goes out here to, whoopsie daisy. Come on. Oh, there was a 0 at like 58 when it's a 59 would be where it hits over there. And what's this other one? I could just go and have it calculate the zeros. This is kind of annoying. But this is entertaining, right, kids? So just watching me do this, of course. So about 8. Well, that was at 808 from yesterday, right? I'm remembering the numbers from yesterday. Okay. So right here about, we'll call it $8. And what did we say it was? 59 or something like that. And up here was, what to figure out, this was some huge amount. It was kind of like that. So this is the profit, right? This is no longer revenue. That's our profit function. Okay, it looks like a revenue graph, right? But remember, this is like the revenue graph where we rotated that expense down to make it be like the x-axis, right? So the zeros, right? So let's figure out. You know, we could do the negative B over 2A business and get that, plug it back in and get the value, right? But you guys know how to do this on the calculator, don't you? I know you do. You must. Let's use this. And go to menu, analyze graph, right? See something that'll work there? The maximum, right? And it's going to ask us to kind of, okay, so there's like the lower bound, right? I probably want to put it on either side, right? Like there, and there, right? And this display, whatever. So at what price do we find the maximum profit? $33.50, right? Okay. Yeah. Don't judge me. 3350. So we use the TI max, right? And we got a max profit of 33.5 at that price. And what's the amount? You would read it that well on there. 323,125. 323. So that's the coordinates of that point, right? So what does that tell you? At a price of, yep. So I'd say at a price of $33.50, right? Max profit is how much? Yeah. Is $323,125. Okay? Now be careful that I don't remember what the max revenue was. We did that yesterday. What was the max revenue? I thought we did that properly. Found the break even. Yep. Yeah, we didn't do the max revenue. Whatever. But it could be different, right? Remember, the max revenue could be different. This profit graph we did here, remember, that's this green thing, which is different than the revenue function, right? And I don't know, where the max was in each one of those, but anyway, it could be different than max revenue. So everybody clear on that? Okay, depending on the cost structure of everything. So yeah, we can start using our technology now that we've learned how to do certain things by hand, right? Okay. Let's move over to example 3. Now they want us to graph all of them, revenue, expense, and profit in the same coordinate plane. Okay. So now I think we're gonna find the max revenue, aren't we? That's where we'll do it. I knew it had to happen somewhere. All right, so we can keep the same graph there on the calculator, right? So we'll get our max revenue and compare and see. All right, so let's put in, set your tab key there. Go back up and put the revenue. Tab revenue is -500 squared plus 30,000x, right? Well, it's a good thing I did make it kind of big, Carly. Oh, how about that? So there's our revenue. Maybe I will open this up just a little bit because I want that max point up there. Menu, huh? It does. Mine does. Why is mine not?
I don't know, I'm saying Windows here.
So maybe I'll go down to no. 0 to what might change? Yeah, it might change for some reason. Okay. All right. Let's do the let's figure out where max revenue is, right? So we're gonna go right. So menu, analyze graph, maximum. Graph. Okay, so we roll it down here, down around there. Do you notice now? Okay, so hey, the max revenue price is different, wasn't it? Okay. So it goes to show you that, So when I ask you what's the max profit, is not necessarily going to be the same as where the maximum revenue is. It's wherever the greatest vertical distance is between revenue and expense. Let me put expense on here now. So tab, and that was negative 3,500, E, negative 3,500. Plus 2,000. Okay, so there's our expense line. And so, as it turns out, our price for max profit puts a revenue down here, like over here, a little bit lower than the max revenue, right? Go vertically down through here. That is the greatest, that's the greatest distance between the expense and revenue. So again, it's like taking the red revenue graph and the expense graph and rotating it down. So now the expenses, and it makes sense for the expense to be like the new zero if you're thinking of profit, right? Because this point is a zero, a break even, that's a break even point. Rotate it down, basically, right? And that's what that blue graph is, okay? So, we'll go back and sketch these in real quick. So we don't have to put, well, let's do this. Just a real quick one. So we have our, this is our max profit, okay? And that was at 33.50. Agree? This was 33.50. So that's our max profit, okay? Then we had revenue. Well, let's see, our expense was like, I don't know. So let's put revenue in here. It's kind of like that. It should come back down about the same spot, okay? And then the expense graph, let me see if I can get that to intersect right above it. So I want to be like right above this point here, right? Because that would be the zero, the expense. Something like this, I don't know. Something like that. That makes sense. I should change the colors here. So that was our revenue. Well, Dylan, be mistaken. What color is that, Dylan? Oh man, that's green. Okay, let's make that one red. Okay. Okay. Yeah, Roy G. Bibbs, all the colors of the rainbow. I've got the whole prism here. All right. So this break-even point, right, for revenue is the same as that zero profit. Break-even is zero profit. Hey, here's my profit, right? And over here, I guess I didn't draw it quite accurately enough. So what was the max revenue? So the max revenue was up here at this point here, right? And that was at $30, okay? We'll just do it like this. At $30, we ended up at 450,000, right? There's the coordinates there, okay? And that's a little different than the max profit, right? 3350 and 323,000. Okay, guys, kind of getting the hang of this here. I don't throw this other graph and equation at you, but if you think of it as just kind of rotating that profit or that revenue down to make the expense line the new axis, it's kind of what's happening here. Because these are the zeros, right? Those are the zeros again. We're just rotating it down so it looks, you know, positioned correctly. Right. So what's example 4 telling us to do here? Let's go to a new page. Everybody got that? Yes. So the idea there, max revenue is not necessarily max profit. Okay, so algebraically determine the price of pencil paint product that yields the max profit. Okay, so we're going to do this algebraically. So we have the profit equation, right? So example number 4. And make sure you know how to do this correctly, right? Because on the test, you know, you're asked to find that it may say do so algebraically, right? So that's the only way you get full credit. So let's make sure we can do this, okay? So the profit equation was negative 500 P squared plus 33,500 P minus 238,000. Okay? So we need to find that vertex, right? We need the axis symmetry, the x equals negative b over 2a, right? Well, this will be our p equals negative b over 2a, right? If you don't remember the negative b over 2a thing, you want to do something for your note card, right? So let's plug these in. What's our b? Negative 33,500 over 2 times negative 500. All right. That's going to be a positive number. Put that in your calculator. Hey, we got, again, $33.50. Okay? Well, now what do we do to find, like algebraically, find the actual profit that comes from pricing our item at $33.50 per? Huh? Well, we found the price that gets us the max profit. How do we now find what that profit is at that price? Plug it back in, right? So our profit at that price, its maximum, will be negative 500 times 33.5 squared, right? So 33,500 times 33.5 minus 238,000. All right, so everybody push buttons and make sure you get the same answer that the calculator gave you, right, on the max on the graph. Did we get the 323, 125? We good with that? Okay, then we'll get to work. All right. Example 5. It looks like we're with a different company now. Jeff determine this profit equation for revenue expense situation. Okay, so we're on a new, so now we're not with Picasso page, right? So we'll skip down here. Everybody have this? All right, make it bigger, I think. Okay, so now we have a profit function, negative 100p squared times price squared, I keep losing my place, plus 24,000p minus 1,600,000. Okay? So at what prices is the profit equal to 0? In other words, what are they asking? When they're asking when profit equals 0, what term are they asking us here? Right, but when the profit is 0, what do we call that point? Break even. So there's 2 break-even points, right? All right. So profit equals 0. We have an equation for profit, right? So this will be, they're asking us to find the break-even points. All right? And it's a quadratic, right? And by the way, that quadratic will equal 0, which is required to solve a quadratic, right? Equaling 0. So negative 100 p squared plus 24,000 p minus 1,600,000 equals 0. So profit equals 0. In other words, revenue minus expenses being equal 0, right? Two things are equally subtracted and you get 0. All right. Hey, use quadratic formula. Remember that? Probably should be on your note card, eh? Right? We know what A, B, and C are, but we're not going to use X, are we? We're going to use not X equals. This is context specific, so we're going to use what instead of X? P, yeah. All right, so let's plug it in there, right? So P will equal negative B, so negative 24,000 plus or minus the square root of lots of stuff there. B squared minus 4 times A times, now what's the value of C? What is it? It's, here's, I'm stopping here to ask that because a lot of kids will just put 1,600,000 in there. Is that what it is? Negative. Negative, negative, that'll make an enormous difference, right? That C is negative, okay? Times negative 1,600,000 all over 2 times A. And we're going to get how many answers here? 2 of them, right? Because that, hey, that expense graph intersects the revenue graph twice. And those are our new zeros. We brought it down to be a profit equation. Right, so let's make sure we can plug this in. Oh, and we're going to run into something that I think it encountered in algebra 2. Let's see if you guys remember. Okay. There. Oh, I know it. You know what? We could have divided everything by 100, by the way. Save us a little work. You guys get what I mean? Like if I took this equation, divided every thing by 100, we can simplify what we have to enter, but whatever. Let's just put it in like that. So we got plus square root of squared minus 4 times negative. All divided by all right. Okay, got it right. Oh, did everybody get this?
Yeah. And then I did it again. Also, it can't be. Right?
What's the, it says non-real answer. What is going on in our quadratic formula that can cause a non-real answer? What part of that quadratic formula do you think the problem is cropping up in?
Square root.
The square, what can you not take the square roots of in the real number system? Negative numbers. in algebra 2, I don't remember if it's still in there, you got a short year, but did you learn about imaginary numbers? I
Yes.
being the square root of -1, okay, all right. So we might end up with a complex number here, right? So that tells you that your parabola does not cross the x-axis, does it? Right? There is a setting in here, right? Let's just take this. Let's just take this thing here, right? And this would be big number, right, minus an even bigger number. So this would be negative under here, right? The square root of the negative is the no go. But let's see. If I go home, I go to settings. I believe this will work. I want to do handheld setup. No. Oh, vacuum settings. 5. Vacuum settings 2. All right, so let's go down to, okay, real. What we want here is rectangular. Maybe. Let me go try and enter this again. See if it gives us anything. Aha! See the I in there? Okay. So that means it's an imaginary number, right? In other words, is there any profit? Is there any that we can measure in the real number system, which is what we use for money, right? Okay. So there is no profit. Do you remember the graphs we looked at right at the beginning of the lesson? And which of those graphs do you think this is? The one with the expense line was above the revenue, right? And so when you brought that down to make that expense line the axis, the parabola was underneath it, right? Okay, so it turns out when you work this out here, you get, you know, if you go through and do it algebraically, you get P equals, what was it? Yeah, negative 240 plus or minus 80 I over negative 2. Okay? So this is a non-real solution. There is no profit. Okay? So in other words, our profit function the parabola is down there, right? Because remember, our expense line came down and was made this p-axis here, right? So that is what happens when you try to find the zeros of a parabola that never hits the zero line. You get square roots of the negative, okay? Does that make sense to you a little bit? Anybody have any questions on this? So again, we're gonna skip the lab at 9.9 optimal outcomes. So this will be it for this chapter, okay? This section right here. Stop.